Hello, today's section is 1.3 Algebraic Expressions. I have this table for you that I'd like for you to put into your notes. You'll notice in the upper left-hand corner all these words mean addition, multiplication, subtraction, and division. You'll notice any of them that have that word than attached to it, so over here more than or fewer than, less than, means that you need to switch the order, so maybe make note of that as you're writing these down. Alrighty, below I have some examples for you to try. So the first one says 7 fewer than a number t. Okay, the key words that stand out to me in this problem are fewer than. Fewer than means that we're subtracting. That word than means that we're switching the order. So the t is going to come up front, the 7 is going to go behind, and then we just subtract those two variables. Alrighty, number 2 says 2 times the sum of a and b. Now this one has two key terms, times and sum. So it says we're taking 2 times the entire sum of a and b. So to make sure that we take the sum, we're going to put it in parentheses. So 2, and then we're going to do parentheses to mean multiplication. And then we're taking, and we're going to add a and our b together. This one without parentheses would be incorrect. Number 3 says you start with $20 and you save $6 per week. Now that word per means multiplication, and so we're taking $6 per week, so 6 times some variable, so maybe 6 times x, and then we started with $20 and we saved $6 per week, so it's going to be 20 plus 6x. Now number 4, it says you start with $20 and you spend $6 per week. So this one's going to be very similar. However, instead of adding, we are going to be subtracting. Alrighty, this next section, it says evaluate the algebraic expression. That word evaluate just simply means solve. So I'm going to give you an expression. An expression is just an equation, but one side instead of having two sides. So I have this algebraic expression here, and let me get caught up, sorry. For this algebraic expression, I'm telling you that a equals -4 and b equals 5. So the first step that we're going to do is wherever we see an a, we're going to plug in -4, and wherever there's a b, we're going to plug in 5, because that's what they both represent. So we just write it exactly the same, but we just substitute in our numbers for our variables. And then from here, we're going to do PEMDAS, order of operations, to simplify them down. So we're going to start with our parentheses, then we're going to go to exponents, and then multiplication, division, addition, and subtraction. Anytime that there's multiplication and division, we go left to right. Anytime that there's addition and subtraction, then we just go left to right to solve for it. So the first step, we're going to simplify inside parentheses. -4 plus 4 is just 0. Everything else I just brought on down. And then from here, we're going to go through and do multiplication. So 7 times 0 is 0. 3 times 5 is 15. And then we bring everything else down. Now, addition and subtraction are on the same level, so we just go left to right. So 0 plus 15 is 15 minus the 8, then we get 7. So 7 would be the correct answer. Alrighty, one for you to try now. So for this one, the expression is x divided by 2 plus y squared. My x is 1 and y is 1/2. So our first step, again, is just plugging in x equals 1 and y equals 1/2. And then from here, we're going to do order of operations. So order of operations, we need to do our exponents first. So 1/2 squared simply just means that we're taking 1 squared and then 2 squared. So 1 squared is 1, 2 squared is 4, so it'd be 1/4. And then we need to add these, so we're going to get common denominator, which is 4. And so then over here in this first fraction, we'd multiply top and bottom by 2. So we'd have 2/4 plus 1/4, which then we just get 3/4 for our final answer. The last one that I have for you is 2 times x squared minus y squared divided by 3. Our x is 6 and y equals negative 3. So our first step is to substitute those in. And then we're going to go through and do order of operations to simplify it down. Now this one's slightly different. Anytime you have an overall fraction like this, you're going to think of the numerator as one problem, the denominator as a separate problem. You simplify the top down to a number, simplify the bottom down to a number. Your last step is going to be to divide. So if we go through and do that, our 6 squared is going to be 36. Negative 3 squared is going to be 9. Make sure you don't cancel these two negatives out. Again, we need to simplify inside parentheses. We're starting then with our exponents first. So we have 36 minus 9. 36 minus 9 then is 27. We're just bringing everything else down. And then we're going to multiply 2 times 27 to get 54. We're going to divide that by 3 to get our 18. Now, the last type of problem that we're going to talk about is combining like terms. Now, you'll notice for this first example that I have for you for combining like terms, that a like term is anytime that a variable and the exponents are the same. If the variables and the exponents are both not the same, we cannot combine them. So for this one, 7x squared and negative 4x squared, notice how they both have the x squared on them. So they're like terms, so we can combine them. So we just combine the front numbers. 7 minus 4 is 3, and then we just tack on the x squared at the end, so it would be 3x squared. And then 3y squared plus 2y squared, those are like terms, so we add the numbers out in front, so we get 5y squared. So our final answer is 3x squared plus 5y squared. We cannot combine these together because they are no longer like terms. Now, number 2, before we can start just combining like terms, we need to distribute this negative here, distribute the 2 here. So if it would help, put in a 1 here. So we're distributing that negative 1. So negative 1 times 3k is negative 3k. Negative 1 times m is negative m. 2 times k is 2k. 2 times negative 4m is negative 8m. Then from here we combine our like terms. It doesn't matter which ones we start with, the k's or the m's. So negative 3k plus 2k is negative 1k. And then negative 1m minus 8m is negative 9m. And we just put those next to each other. They're not like terms, so we can't simplify this problem any further. The last one, we have negative 4j squared minus 7k plus 5j plus j squared. We have this j squared here, our j squared here, so they're like terms. So negative 4j squared plus 1j squared. Negative 4 plus 1 is negative 3j squared. I bring down my negative 7k and my 5j. None of these are like terms, so I cannot combine them any further. Even though this is a j and this is a j, their exponents are not the same, so I cannot combine them.